Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of a galvanic cell. What is a galvanic cell? Well, it's a cell composed of two half cells, here and here, one being an anode, another one being a cathode. I'll describe those later. And basically an external circuit, a salt bridge, and when you close the circuit, what happens is you get a spontaneous redox reaction. So no outside energy or driving force is required. So what is going to happen is we will have an electron flow going from the anode to the cathode. What are these words I keep using, anode and cathode? Well, anode is the electrode, being one of these two metal bars I've drawn here, in which oxidation takes place. If you forgot your activity series rules, basically the further down on your table you are on your activity series, the more easily it'll be oxidized. Okay, so we're going to have anions moving towards this anode, and oxidation is going to leave electrons behind, making the anode slightly negative. We say it's got a negative polarity. Okay, and the cathode is going to be where reduction takes place, and upon reduction, the cations come out of the solution onto the electrode, making it have a slightly positive charge, or a positive polarity. And cations are attracted to the cathode. Alright? The shorthand notation of this thing is going to be anode, metal, this is solid, this is the electrolyte, it's usually going to be a cation, and then a solid for the cathode. So in our example here we have copper, solid, copper electrolyte. Notice I'm only writing the cation here. The electrolytic solution actually is composed of, in this case, copper nitrate and silver nitrate. But we only care about the cations here. We're doing a single replacement reaction when we do these here. So basically, let's get detailed. Oh, before we get detailed, we have a salt bridge. The salt bridge is a tube filled with salt solution made of ions not involved in the reaction. So in this case, KNO3 or KCl could be used. Notice NO3 is more of a spectator ion. It's not doing any of the redoxing. So what happens is you exchange with the half cells. Anode, you're going to need anions in the solution of your anode here, because what's going to happen is when oxidation takes place, the electrons are left behind on the copper wire. Let's see if I can find that picture I drew. And the copper literally comes off the bar into the solution. Okay, so what we have is a bunch of these 2+ charges, these spheres, all have a 2+ charge. Well, what the salt bridge will do is it'll donate an NO3 to neutralize this electrolytic solution. That's one of the main purposes. Or it can pull some of this copper out onto the salt bridge, which is not drawn in this diagram. It's drawn in the big one, but here's your salt bridge. Okay, so some of this copper can come out. There's usually a porous plug here at the end of it, and or you can have some of the anions coming out to neutralize the copper. So what's going on at the silver end? Well, on the silver end, we're getting those electrons that the copper oxidized, right? It released these electrons. So copper is the oxidizing agent, or is it the reducing agent? Well, in this case, even though oxidation is taking place, copper is the reducing agent. It gives up the electrons so that oxidation can take place. Okay, and then these electrons go across this circuit here that's connected, and electrons will go that way, and they're going from anode to cathode. I just drew the anode on the left. It doesn't matter which order you draw them in. And once they get over here on this side, this is what happens. You end up with the electrons coming onto the bar, right? And the silver nitrate, that's the solution. I went ahead and wrote this one out for you. Silver nitrate, once it gets put in the solution, ionizes. When it ionizes, this silver right here gets attracted to these electrons on the bar. And it literally comes out of the solution and goes onto the cathode. Okay? And what happens is you get a slightly positive charge here, giving it what's called a positive polarity. Okay? So in the salt bridge sense, what's happening? Well, our salt bridge is going to try to neutralize this reaction here. Right? So what do we have going on? Well, we have a bunch of the plus charges going onto the bar, and basically leaving a bunch of minus charges in the solution, just hanging out, doing nothing. So if too many of them accumulate, then it'll be negatively charged. So what you do is you need to pull out some positively charged species out of your salt bridge and put them with the negatively charged species in your solution, thereby neutralizing that solution. Okay? That was a lot of information, but very understandable if you just take each piece of the puzzle one by one. Okay, so first know which one's the anode, which one's the cathode. Oxidation takes place at the anode, even though it's got the reducing agent here. It's opposite, remember. And cathode reduction takes place, but this is the oxidizing agent. Silver plus. Oxidizing agents are usually cations. And reducing agents is going to be the solid that gives up the electrons so that reduction can take place. Alright, once you know that the salt bridge neutralizes the electrolytic solutions. Electrolytic solutions are going to either at the this is actually the anode. At the anode are going to pull stuff off the bar into the solution and give the electrons to the cathode. Once the electrons get here to the cathode, they pull the silver out of the solution and thereby make it slightly positive. And then this is a spontaneous redox reaction. All that has to occur is the closing of this circuit here. Alright, I hope that has explained a galvanic cell to you. You might need to watch this a couple times. I will do another example video. There's really no concept video. These are one and the same. You should be able to, given two metals, determine which one is going to be the anode half cell and which one is going to be the cathode. You should also be able to understand what's going on at each of those. Alright? I hope this has cleared it up. Practice, practice, practice. Thank you and have a nice day.